It's the surrounding force of our world. It's a staple for policemen everywhere. It's the foundation of the planets. It's the basis of God's greatest gift to mankind. And they're completely pointless. Okay, enough of the dramatics. But if you haven't figured it out by now, today we're going to be talking about circles, specifically sector area and arc length. And yes, you heard me right, circles are quite pointless. We just acknowledge how hot circles are. I mean, not just because of all those curves, but because they're 360 degrees. And I know that my puns seem like they're on an endless cycle, but I assure you they're very well rounded. Now, let's get the ball rolling and jump right in. Let's start off with the sector area, which is a sector or a portion of the entire area of the circle. Has a nice ring to it, don't you think? Think of it in a sense of a pizza. Your actual whole pizza is the entire area, and the sector area is just about as big as a single slice. Now, while I'm sure that we'd all love to have an entire pizza instead of a single slice of pizza, there's sometimes other good things to save room for, like cake, or cookies, or spears of ice cream. Wow, that one's really bad. Arc length is the distance along the arc, specifically of the sector that you took out of your area. Going back to our pizza example, arc length would most likely be the crust of that pizza, or the frosted top of the cake. Wow, is it time to eat yet? So now is where all the math comes in. And yes, I know starting off with puns is probably a pretty big sign of a very big problem coming up. But don't worry too much, because our plan isn't foiled. Don't get stressed out like our buddy 1/5 because he sure is 2/10. Don't stress about this being too difficult. It's a slice of cake. Or pie. So let's head to the drawing board because we got 99 problems and we're only doing 6. See? 1, 2, 3, 4, 5, 6. So let's get on it.
Welcome to the drawing board. It is a mystical place full of multicolored drawing pixels, happiness, unicorns, and of course, math problems. Our first 2 problems will deal with arc length, then the next 2 will be sector area, and the final will be word problems. Let's start out with our first one, which reads, a circle has a radius of 4 inches and an arc with a 120-degree central angle. What is the length of the arc? So let's start out by drawing all of this out. We know that our circle has a radius of 4 inches and that our angle is 120 degrees. The formula that we use for arc length is n, which is our degrees, divided by 360 times 2 times pi times r, which is our radius. So, plugging in our numbers, we get 120 over 360 times 2 times pi times 4. And we put that into our calculator, and then we get 8.37 inches as our final answer. But we always want to round up, so that will become 8.4. Alright, problem 2 reads, a circle has a diameter of 18 inches and an arc length of 24 inches. What is the central angle in degrees? So this time we are finding the central angle, where last time we were just finding the arc length. But don't panic and just remember your equation. N divided by 360 times 2 times pi times r. Let's draw our circle to get a better understanding of what we are dealing with. We know that the diameter is 18 and that our arc length is 24. Now plug in what we know into our equation, but first we have to remember that our radius is 9. Remember that the diameter is the entire distance across the circle, while the radius is only half, so we have to divide 18 by 2 to get 9. Back to our equation. We don't know the degrees yet, so we put a theta in its place. Our equation becomes theta over 360 times 2 times pi times our radius, which is 9, is all equal to 24, since that is our arc length. Now we work backwards. Let's multiply each side by 360 so that we don't have to deal with a fraction. Now we're left with theta times 2 times pi times 9 is equal to 24. Or, I'm sorry, I forgot to multiply, which is equal to 8,640. Now, we divide both sides by 2 pi times 9. And we get theta to be 152.78 degrees, which we will then round up to 152.8 degrees as our answer. Our next two problems are dealing with sector area. The first one reads, a circle with a radius of 5 inches has a sector with a central angle of 120 degrees. What is the area of the circle? Before we jump in, let's remember that the formula for sector area is n over 360 times pi times r squared. Now, let's draw this out. We know that our circle has a radius of 5 and a central angle of 120 degrees. Now let's use this in our equation. 120 over 360 times pi times r squared, which is 5 times 5, which is equal to 25. And we plug that into our calculator in order to get that our sector area is 26.17 inches squared. And it is squared because we are dealing with area. So your answer will always be squared whenever you're dealing with area. Problem 2 reads, a circle with a diameter of 16 inches has a sector with a central angle of 60 degrees. What is the area of the sector? Alright, let's draw it out. We know that our diameter is 16, so that means that there is a radius of 8, and that our central angle is 60 degrees. Now let's plug that in with our equation in order to get 60 over 360 times pi times r squared, which is 8 squared, which is 8 times 8, which equals to 64. And when we multiply all that out, we get 33.5 inches squared. Now let's move on to our word problems. Our first word problem reads, Richard's Pizzeria hired 2 new employees, Ricardo and Ricky, because he liked their names. Unfortunately, they were terrible employees. Before they were fired, they made an odd-shaped pizza with a diameter of 13.1 inches, and they accidentally burned part of it. Richard wanted to save whatever pizza wasn't burned. If the central angle of the burned area was 120 degrees, how much of the pizza does Richard have to toss? There was a lot of information in there, so let's pick out what we need. First, we need to determine what kind of problem it is. Since we're asking how much of the pizza we need to throw out, we know that it's sector area, and the formula for that is n divided by 360 times pi times r squared. So let's draw it out and then plug it into our equation. We know that the diameter is 13.1, so that means that the radius is 6.55, and we know that the angle was 120 degrees. Our equation now reads 120 over 360 times pi times r squared, which is 6.55 squared, all equals out to be 44.9 inches squared of pizza that needs to be tossed. Alright, our next and final problem reads, Alex was spray painting a circle on his lawn where he was going to plant a bunch of flowers so that his house would look better than his neighbor's Ralix, because Ralix beat him in the gnome competition. He wanted to have a diameter of 170 feet to maximize his flower space. He had only spray painted a portion before he got distracted by an ice cream truck and wanted ice cream. If he was working at an angle of 145 degrees, how many feet has he shaded? Once again, a lot of information, so let's pick apart what we need to know. Well, we know that the diameter of the circle that we have is 170 feet. And the central angle was 145 degrees, so we're finding the sector area because we want to know how much of that sector he is actually spray painted. Let's do some quick math. And 170 divided by 2 comes out to be 85. So we know that our radius is 85 feet. And once again, there is our formula. So our equation becomes 145 over 360 times pi times 85 squared gives us our answer, which is 9,142.25 feet squared, which is going to be a whole lot of flowers.
And that's all there is to it. Finding the sector area and the arc length is pretty simple once you're looking at it with a rational sense. And maybe I'm going on a tangent with all of these puns, but they sure are in the right domain. These puns should be a sin, but I don't see anything stopping me. Okay, I'm done now. Knowing how to figure out the sector area and the arc length sure will make you smarter than a lot of monsters, because they're really bad at math. Unless you count Dracula. And just remember, you have to be odd to be number 1. See you next time!